Hey, good morning, Calculus 1. I wanted to teach you about limits. This is kind of where the course starts. I tried to, in my previous video, I tried to say, what is calculus? That was a little tough, but I did it in 12 minutes. So now let's get started. Let's do some limits. So I might talk a little bit about 2.2 and 2.3, just some quick examples. There's a lot to discuss in these ideas, but I like to do these quick videos, so we'll see what happens. Anyway, here's the first definition of a limit. There's another more formal definition, but this is the first definition of what a limit is. What we do is we write LIM, the limit, as x approaches c. That's how we read it. The limit as x approaches c of some function f of x, and the answer is L, some number L. So the limit of the function as x approaches c equals L, is L. And here's what that means. It means as x gets arbitrarily close to c, we're going to let x approach c. So as x gets closer and closer to some number c from both sides, we're approaching c from both sides, then the function gets arbitrarily close to L. So I'd like to point out that the L, the answer, is a y value. The answer to a limit is a y value. Some students get confused. As x approaches some x value, the answer to a limit is a y value, L, that the function, that's a y value, the function gets close to L. So that's it. And I want to do a few examples. Now, the way our book starts, we start in section 2.2, and we do limits numerically and graphically. And then we move to 2.3, and we do limits analytically. And I think I want to do one of each of those examples for you real quick. So I start with this problem. Here's a limit problem. This is the limit of a function as x approaches 0. This is the limit of a function as x approaches 0. That function's kind of strange. It's sine x over x. I don't know the answer, but I think I'm going to figure out the answer. I'm going to figure out this answer numerically. One of the things I like to say is step one of doing limits, though, actually, is you plug in that 0. If x is getting so close to this number c, you go ahead and plug in c and see what happens. You might get an answer. So I'm a fan of saying step one of doing limits is plug it in and see what you get. But the interesting problems are when this happens. Watch. When you plug in a 0, the sign of 0 is 0. There's a 0 in the denominator, and so we get this 0 over 0, which is known as indeterminate. Indeterminate. In pre-calculus, anytime you divide by 0, you call that undefined, but we don't stop here and call this undefined. In a limit context, this needs further exploration, and we can explore it numerically, graphically, or analytically, perhaps, to try to get an answer to this. It will have an answer. So numerically means you build this chart and you try to let x get really close to 0, and you try to find the y value. So maybe I'm going to start over here. I'm going to plug in a 0.1. By the way, on a number line, I'm trying to let x get really close to 0 from both sides. That's what we mean by from both sides. So I'm approaching 0. I got a 0.1. I'm going to plug in a 0.01. That gets me closer. 0.001. Over on the other side, I'll plug in a negative 0.1, a negative 0.01. That gets me closer. A negative 0.001. And watch and see what these y values are approaching. So I want to fill in these y values. So this is a little tedious. You need a calculator. You need to understand that you're plugging in these numbers into this trig function. You should understand that you should be in radian mode. These numbers are not in degrees. These numbers are radians. So I want to try this. I want to try plugging in a 0.1. So that is the sine of 0.1. I hope I'm in radian mode. Divided by 0.1, and I get some little number. Let me just check my mode. Yeah, I'm in radian mode. And so I've got this 0.99833. So that's my answer. Let's try a 0.01. What is the sine of 0.01 divided by 0.01? And ooh, that's a little better. That's a 0.999983333. That's interesting. Let's try the other one. The sine of 0.001 divided by 0.001. Wow, 0.999998333. That is interesting. I can do this on the other side. You know what I'm going to do? I'm going to skip these guys. I'm going to just get really close, and I'll try this guy. What is the sign of negative 0.001 divided by negative 0.001? And the answer is, wow, 0.999998333. All right, anyway, can you conclude what it might be when I get x to equal 0? Wait a minute, that's not what I'm saying. Remember, we already know what it is. When x equals 0, we are undefined. But what about the limit as x gets really close to 0? Can you tell me what that is? As x gets really, really close to 0, what is this number? What y value are we approaching? And I think you can tell it's 1. The answer to this is 1. The answer to this limit is 1. Originally it was indeterminate, but we've done this problem numerically. We can see that it's a 1. The limit is 1. This is a function. And if I asked you to plug in a 0, you do get undefined. If I ask you to take the limit as x approaches 0, you get 1. And we prove that numerically. Let's look at this problem. I'm making a graph. I'm making up a graph, some kind of curvy graph. It has a hole right there. When x is 2, there's the y value. And it has this colored in dot here. So there's a graph of some function. And that hole means it doesn't exist right there, but it's colored in right there at x equals 2. So I have two questions for you. What is f of 2? That's a question, and that's a kind of a pre-calculus question. And here comes a calculus question. What is the limit of this function? I don't have an equation for this function, but I got a picture of it. What is the limit of this function as x approaches 2? So these are two questions, and here we go. Well, this question says that there are two different questions. There are going to be two different answers, and I think they're two different questions. This question says, when x is 2, what's the y value? And this question says, as x gets arbitrarily close to 2, what y value are we getting arbitrarily close to? As x approaches 2, what y value is the function approaching? This says when x is 2, what y value are you at? And I think you can see from the picture, when x is 2, it's defined right there to be that y value 1. I think you can see from the picture, as x gets really close to 2, from both sides, you're on the function, you're getting really close to 2, but you're on the function and you're approaching this y value. Even though it doesn't exist there, even though there's a hole there, that limit exists. That limit is 4. I mean, if we're at 1.9999999, I think we could look up here and we'd find the y value to be 3.9999999. I think if we're at 2.0000001, you could come up here and find the y value to be 3.99999, or so, anyway, something very close to 4, as you can tell. So as x approaches 2, the y value approaches 4. We just did that problem graphically by looking at this picture. By the way, if this dot wasn't filled in, this is kind of the same kind of question, although what would change? This limit question would still have this answer of 4. This function question, though, would now have an answer of undefined. I think you would agree with that. When x is 2, please tell me the y value, and now there isn't one because I changed the problem. So, all right, let's do another one. Let's do one analytically. I'm going to erase these, and I'll do a problem analytically. And so it's this classic problem. I made up this problem. I want to do the limit. As x approaches -1, I've got x squared minus 5x minus 6 all over x squared minus 1. So I'm not going to build a chart and do it numerically, although I could. I'm not going to sketch a graph and look at it graphically, although I could. I want you to learn all three ways, okay? We want to learn all three ways. Some homework is going to tell you to do it numerically or graphically, and some homework is going to tell you to do it analytically. On a test or a quiz, I might ask you to do it one of those ways. So sometimes students think, oh, I'll just learn one way and I'll do all my problems one way. We want you to learn everything here. So check this out. Most of the time we do them analytically. Most of the time we do these problems analytically. So do you remember step one of doing a limit? Step one of doing a limit was plug it in, see what you get. You might get an answer. I mean, you might get 2/3. You might just get a y value and you're finished. But usually the more interesting problems you have to explore and fix and figure out. Like this one, if you plug in a -1, that's 1. A -1 there is +5. That would be 6 minus 6. That would be 0. Nothing wrong with a 0 in the numerator, but when I plug a -1 in there and square it, it's 1 minus 1. I got a 0 in the denominator. So here I am again. I'm indeterminate. And I do not stop there. And when it's a limit question, I can probably figure this out. I'm going to do it analytically I'm going to use factoring. If I can do some canceling here, I bet you I can figure this problem out. There's other analytical methods besides factoring, but factoring is one of the first ones. Let's see, does that numerator factor? I think it does. You know, x and x, minus 6 and plus 1. Did I do that right? That's a -6x and a +1. Yeah, that's good. That's it. The numerator is factored. The denominator is the classic difference of two squares, x plus 1, x minus 1. Hey, now I can see why I get that 0 over 0. When you plug a -1 in this factored form, there's your 0 over 0 right there. And you can cancel that away now and try the limit now as x approaches -1 of what's left. So this is canceled away, and try plugging in a -1 now. The numerator is a -7, and the denominator is a -2. The answer is 7 over 2, or 3.5, or 3.5, 7/2, positive 7/2. That's the answer. As x gets really, really close to -1, the y value of this function gets really, really close to 7/2. The answer to this limit question is 7/2. When x is -1, this function is undefined. It's probably a hole. These holes, these things that cancel away are these holes. There's another undefined place on this function. When x is 1, it's undefined. I wasn't asking about that. But when x is 1, I think I've got a vertical asymptote. So there's these undefined bad places that make for interesting limit questions. Okay, that's enough for this video. Get to work, do some homework, and I'll help you with some more limits as we get going here. Numerically, graphically, analytically. There's a lot of good questions. I'll tell you what, one more. There's one more. Here's one more back to graphically real quick. Some limits don't exist. Watch this guy. We'll call this 3, -1, and then we'll call this 2. See those y values? And see this function? This function is like broken. That's not a hole or an asymptote. That's just kind of a broken function. Anyway, it's some function f of x. And I'm interested in this. Here's a question. What's f of 3? What's f of 3? Maybe you can see where it's colored in. When x is 3, it's colored in. It's defined right there to be this y value, -1. So there's no problem. What is the limit as x approaches 3 of this function? And this is interesting. Remember, these limits are two-sided limits, although it won't be long. We'll learn about one-sided limits. I could go ahead and tell you. But these are two-sided limits. We're approaching 3 from both sides. And a limit has to have one unique answer. So if you ever think there's two answers to your limit question, the answer is that there is no answer. And the limit does not exist. That's the answer here. As we approach 3 from one side, we're approaching this y value of 2. Again, as you get as x gets really close to 3, we're approaching a y value of 2. I hope you can see that from that side. From this side, when you approach 3 from this side, you're approaching a completely different y value of -1. And you actually get there. But that's not the point. The point is, from that side and from that side, we have 2 different limit answers, and what that means is this limit answer does not exist. This limit does not exist. Often we just use the answer dne. Does not exist. So, not all limits exist. This one did. We did the math, we found this answer. This limit did not exist. All right, thank you. Try some homework.